Here is the HRT-style expected value question that makes smart candidates answer too fast. A fair coin is flipped until the first heads appears. If heads appears on flip n, you get 2 raised to the power of n dollars. How much should you pay to play? Most people see the formula, shout infinite expected value, and think the interview is over. It is not over. Let us compute the expected payout. The probability that the first heads appears on flip n is 1 divided by 2 raised to the power of n. The payout is 2 raised to the power of n. Multiply them together and the term is $1. Every possible value of n contributes $1 to expectation. 1 plus 1 plus 1 forever diverges. So mathematically, the expected payout is infinite. That is where candidates get trapped. They think infinite expected value means pay any finite price. But an interview is not only asking if you can write down a divergent series. The real question is whether expected value is the correct decision rule for this game. In trading, the answer is usually no. Look at the distribution. Half the time, you win $2. 3/4 of the time, you win $4 or less. 7/8 of the time, you win $8 or less. The huge payouts exist, but they are unbelievably rare. The mean is pulled upward by extreme outcomes that you may never live long enough, fund enough, or be allowed enough attempts to see. The correct diagnosis is this. Expected value is a calculation, not always a decision. If the interviewer asks for mathematical expected value, the answer is infinite. If the interviewer asks how much you should pay in the real world, you must talk about bankroll, utility, risk limits, counterparty limits, and the number of times you can play. Now, suppose the casino caps the game at 20 flips. Then the expected payout is no longer infinite. There are only 20 terms, and each term contributes $1. So the expected payout is $20. Suddenly, the decision becomes grounded. If the entry price is below $20 and you are risk neutral, the bet has positive expected value. If the entry price is above $20, it does not. Now, suppose you only have $100 and you can play once. Would you pay $90? The expectation may look attractive in some versions, but the probability of a tiny payout is still enormous. A risk-neutral, infinite bankroll agent and a real person with finite capital should not give the same answer. This is exactly the distinction interviewers want you to notice. The prescription is simple. First, compute the expected value. Then ask whether expected value is the right objective. Check the distribution, the downside, the cap, the bankroll, and the utility function. If you only say infinite EV, you solve the math and miss the interview. So the final answer is not a single number, unless the interviewer specifies the decision rule. Mathematical expected value is infinite. Practical willingness to pay depends on constraints. Diagnosis. Expected value is not utility. Subscribe to the Quant Doctor for more quant interview diagnoses.